This is the bioinformatic pipeline, and I'm not even going to attempt to go over this because I'm not a bioinformatician, and I just, all I can say is two things from here. It goes through the regular alignment and filtering that all bioinformatic processes go through. There is an error correction in there that I believe is really good for detecting large indels, as you can see. Fortunately for what we do in large panels, the largest indel that we do is an EGFR indel, or we actually do duplications in the KIT gene, and it works really well for what we did there. So how did we determine? Just a few slides on the accuracy of the assay. We did about 55 samples, and as you can see, the variants we used were from the regular, your BRAF, KRAS, EGFR variants, and if you pick 3CA, we did some STK variants. We did a MET exon 14 skipping variant, KIT deletions, and the T790M in EGFR, which everybody wants to try. The number of samples is in the second column, and the allelic fraction for these samples, as determined by our previous assay, is in the last column. So we used samples with allelic fractions from about 5% to about 80%, and we compared the allelic fractions obtained in our previous assay with the assay, the current assay, and this is our correlation plot. As you can see over here, the correlation coefficient is excellent. There is very good correlation between the previous assay and the current and the Pillar assay. Some details on the samples that we used. For this particular evaluation, I focused a lot on indels because I know sometimes those could be a problem, particularly with amplicon-based technologies. And as you can see here, they worked pretty well, the EGFR indels, the STK, and the KIT indels, and this is a whole lot. We tested one thing I want to bring to your attention over here. There was one sample where we did not find a variant in the previous assay, but we did find a variant that was, I believe, a FLT3 variant. Not dwelling on it just now, it's a FLT3 resistant variant, but this is a solid tumor panel, so I'm not going to dwell on it. There was one sample that could not be sequenced by the TruSeq, but we were able to Sanger it. Sanger is much more forgiving for those of you who know Sanger. And we tried this sample on the Pillar technology. We tried it twice. The first time it gave us some problems. The second time it worked, but still with low coverage. And I wouldn't confidently say that it was really excellent for reporting. This is a problematic sample. We went back into re-extraction, and then it worked much better.